as you know, those of you who've been watching the stream lately, we've been doing some packaging things. And the first time we packaged together the game, we ended up with almost 300,000 files. And we've been working on packaging for a few days and consolidating the data in the game. And now we've got it down to just under 50,000 files. The game's not done, not even close. So by the time this game would be done, it might be 10 times as many files. That's a lot of files, right? And in video game development, we have strategies for mitigation of that. And it's usually packing data into a fewer number of files. One example of that we've been doing over the past few days is like these all paint data files. Now we just have 700. There's one per level. There used to be, I forget how many, tens of thousands of them, let's say, right? There used to be probably 30 or 40,000 of them, right? Probably about the same as the number of light maps. And for the entities, same thing. We had over 100,000 entity text files. And now there's just one entities file per level. This is all the entity data consolidated into one file for each level. And that's been working great. That's one strategy that we have. But another strategy that we typically do in game development is we don't ship like a file system full of loosely bundled games unless we're indies using Unity Game Engine, right? Usually we package our files together, and that allows us to have a much smoother install and to be much more efficient about finding files and so forth. And you might, like if you start getting philosophical about it, you might wonder why that is. Like if you've got a package with like a directory full of files, file names, and offsets into the file, right? Why is that any better than your operating system just storing directories and data on the disk, right? Why pack it together? Isn't that just like a redundant encapsulation that isn't helpful? But actually it's very helpful, right? Because the thing that you have to think about is when your operating system has all these separate files, it is trying to solve a much more general problem that has, as a result, much more unpredictable and generally slower performance parameters, right? This is actually a very true thing across all software development. When you're solving a specific problem, you can often be very efficient. And when you're solving a general problem, you often can't be very efficient because efficiency requires assumptions sometimes, right? Or invariance that you can guarantee. And the more general you're trying to be, the fewer invariants you can guarantee. So it ends up being a good idea in game development to put a bunch of little files together into big files. And so I just said we sort of did that with this entity data and this paint data, but those were very specialized formats where it was like, we know every level has some number of entities. Let's put the number of entities. Let's put the entity IDs for all those entities, and then whatever the data is that needs to be in an easily readable format in binary, right? That is a little bit more low level and crunched it down because it's not like there's individual files that are addressable within that data. You could kind of think about it as if there were, I guess, for that particular format, but there's not really, there's no like table of contents, right? And there's no file names in there, right? But from a game developer's point of view, sometimes you want to pretend like you have files and file names. And in fact, maybe in a development build, you want those to actually correspond to real files on disk, right? And during shipping of the game, you don't, right? You want those to just be entries in a package, right? This is something you can do quite successfully. I did it on Braid. I did it on The Witness. We're going to do it again on this game. Why do you want to do that? Well, like I said, the operating system is trying to solve a much more general problem. Oh, dear. I hope the dishwasher is not making too much terrible noise. We're just going to fight through it. If that sounds weird, it's not a Sarlacc pit. It's my dishwasher. So for example, the operating system doesn't know which of those files you want to load separately or together, right? It has to assume that you might want to load each one separately. So they're not located very near each other with regard to whatever your device block size is or anything like that. With SSDs, that tends to matter less than physical hard drives, but there's still issues, right? Secondly, your operating system is very concerned with the fact that you might delete any of these files at any time, right? That in the middle of a deletion process, your power might shut down. And when you power back up, it has to be able to salvage all this correctly. Like all these things place constraints on the way data can be stored, how much redundancy there has to be in the way information is stored, and et cetera, right? And the way data is read when you read a file and written when you write a file, right? Now, if we know we're never going to write any of these files because they're read-only packages full of game data, and we know we're never going to delete any of them, and we know which ones we want to go together because they represent various zones of a game, then it makes a tremendous amount of sense to pack them all into one file because that eliminates that operating system overhead for thousands or tens of thousands of files, right? And then when you think about operating system overhead like that, keep in mind also if you're shipping on multiple operating systems, that overhead is unpredictable in magnitude and in like variance, like is it consistent overhead or random, depending on which operating systems you're deploying on, right? And they may even change over time, you know, when somebody releases a security patch for your favorite operating system. So you want things to be in your control as much as possible. That is how you guarantee a good experience to your players. Okay, so what we're going to do today is make a simple little package format. And then hopefully we can get the game using it, and the packager, well, first we need the packager to like write out the packages with the data, and then we can get the game using it. We'll see. That might be a little too ambitious because it's nighttime, but we'll see how it goes. You know, like I said, I've done this before on a couple different games, and I'm about to do it again. Actually, I didn't write the package format on The Witness. Somebody else on the team did, but you know, we used one. But I wrote two on Braid actually, because I switched. And for this one, we're just going to write one that's very simple, and we're going to make it available to the users of the compiler as well, right? And so we're just going to kind of start from scratch and do this. The way it's going to work, okay, so I want to provide good functionality to people, but I also want to be reality-based about the way computers work today, right? Because that can simplify the API, for example, right? Or the intended use case of the package. So a plain fact about computers today, PCs, is a development PC probably has a lot of RAM. I don't even know how much this one has. It's maybe 64 gigs. Let's find out. It might be less. It might be as low as 16. Let's see. How do I find out the RAM? 32 gigs. I was in the middle. So this has 32 gigs of RAM. And of course, if you use more than that, it'll start using swap and so forth. But what that means is if I want to make a batch program that builds packages, I could kind of use up to 32 gigs and not really worry about it, right? And if I do start to worry about it, I could just buy more RAM. RAM is pretty cheap. Let me look up. So DDR4, 3200, 3600, you get some pretty fast RAM, right? It's pretty cheap, like $100. You probably want, if you want a lot of RAM, you would get larger packages, and the price probably goes up a little bit. But so I don't know, everybody wants 16 gigs times 2, but you could find probably bigger packages. Anyway, the point being, compared to programmer salaries in the San Francisco Bay Area, these prices are nothing. You would order like 20 of these and not even think about it if it saved you some time, right? So the plan is going to be like, look, I don't think this game will have a disk image in the end that's bigger than 64 gigs, especially compressed, but probably uncompressed as we build the packages. And we're going to build multiple packages anyway. So one package at a time, probably not more than 5 gigs, if that, because we want our packages to be small enough that we could load them into and out of RAM in a zoned way. And so it's just like, look, the way we do this is we're going to build packages in memory. And then we're going to write them to disk in a post pass. And then later, if we want to parallelize things more, we could have a more complex version of the API or more steps that you opt into where you can flush things out to disk early so you don't have as large of a footprint. But in general, it's going to be like, look, we just build our package in RAM and we write it out. And there we go, right? Okay. So let's get started. Like this is literally a greenfield thing. I'll show you what I did in the game already today in preparation of integrating this, if I'm even updated. Let's see. I think, oh, nope, there we go. See, I added this file, packages, and we'll go and look at what that is. Whoops. Packages. All right. Is really nothing. This is like the interface between the game and whatever the package system is going to be. I was like, okay, maybe we're going to mount packages when we start up and they pretend like they're in the file system, and then you can look up file names, and instead of looking on disk, we look in the mounted packages to find them, right? So you would call get file from package. To do that, literally these are just stubs right now. Package is void, but I just started doing this to be like, what kind of things would the game want, right? So if I go to Vertex Paint, normally, let me see if I could find a read entire. So read entire file is a thing that we use all the time. Again, because, so the old style Unix way of doing file IO is, oh, I want to start reading a file. I'm going to read it one line at a time from disk and like try to parse it or something. And then maybe if people are fancy, they try to mmap it or something. But again, your machine has so much RAM and your files are so small that that's really not a good modern way to do it. So the file primitive that we use almost all the time is read entire file, right? We just read files and then we do stuff with them. And so if we're loading one of these paint datas, we just read the whole thing and then we do whatever we're going to do with it, right? And then we free the data. We had a call to that down here, read entire file, and I just changed that to a thing that says read entire file from disk or package, right? But other than that, it's a drop-in replacement. It has one extra return value that tells us if we actually got it off the disk, which right now means it's allocated separately, and then we free the memory if it's from disk. We don't free it if it's from a package, because if we look it up in a package, we're just going to return you a substring of that package. So there's no allocation that happens to load the data, which is actually another benefit of looking up data in a preloaded package, right? And so this read entire file from disk or package, again, it's sort of basically just calls into those stubs we just looked at. It says, hey, if packages are active, which is a global that's always set to false right now, then we try to call those, right? And if we're super lucky, then during tonight's stream, we can make this actually work on some live data in the game. If we don't get that far, that's fine. Etc. I feel like I'm going to drink a lot of tea. Any questions about what I've said so far? Because we're going to start programming now, and I want to make sure that all the context is there. On-topic questions about what I have said, please. Anyone? Bueller? Tea water's boiling. You have until it's done to ask a question. What is a package here in context? Yeah, well, it's just a file full of other files, right? It's a bunch of files put together into one file, and that file format may have some things that let you do whatever you want, right? An example, so a zip file, right, which everybody knows what it is a special kind of package format where it's got, you know, a table of contents, which is a list of file names and pointers into there of where the data is. And then, you know, of course, the thing about zip files is they compress things. And so in that table of contents, there's also like, oh, this file foo, it's compressed using this compression algorithm, and it's at this offset. And then when you read things out of the zip file, you decompress, right? Here, we're going to be even simpler. We're not trying to do compression tonight. We're just saying this is a file full of other files. That's all we're doing. Do I expect to be able to hold all packages in memory? For this game, eventually, no. But that's sort of a domain-specific thing. Like, you decide for your game how big the packages are and what's in them, right? So part of the intended use case for this is you have a significant number of packages for your game, but way fewer packages than like the number of actual on-disk files, right? Now, we might add compression later. But, you know, in games, you typically want to adjust the compression even per platform because now there's hardware compression on some consoles and stuff that you want to use. So we're not going to like be very serious about building that into the format. That's going to be more like up to the user, right? We might put some user data slots in there. We won't even do that to start, but we might put some user data slots that are like, in fact, it would be fun to have a configurable number at the top of the header that says like, here's how big the user data is for each of these directory entries, right? And you can store whatever information you want. It's a fixed size record, but it's stored in the file format, so you can expand it as much as you want. Like, that would be cool. Okay, the water is boiled. So we're going to start programming. Are you going to read the chunk size based on the underlying file system cluster size? No, I mean, we're going to load the entire package at once. That's just what these are for. What files do you include in these packages? Just assets. Whatever is in your game. So in this case, light maps, which are like texture data, materials, which go on meshes, you know, all these entities and the level data, like levels, or sorry, yeah, I mean, all these entities files are in, you know, one folder per thing. So they might all be in one package because we don't really want to, like, these are small, so there's not really much benefit in streaming them in or out. So these might be like in a globally loaded package, for example. We'll see. You know, we can decide later what goes in which package as well, right? Okay. Let's start programming. We're going to make this a module that all the people who are in the compiler beta can use, right? And I actually don't know if I want to call it simple package. Let's not forget to add the file. And you know what? I think I want to make, I already did the wrong thing. Because I think I want to have examples and a data file that represents a correctly written package and stuff already. So we're going to make this, instead of a single file module, it's going to be a folder. So we're just going to go simple package, and we're even going to make an examples. Examples. Is it rmdir? Is that? Yeah. Okay. So now this, let's just kill this file. Modules, simple package, and then module is the file that gets loaded. Now, actually, I think I want the data structure for reading the package, like creating the package is different from loading the package. And so I think I want them to have different data structures. So what do I call it? So we're going to have some functions that are like create underscore whatever to make the package and load underscore whatever. So we're going to have two sections, create whatever, right, and load whatever. Now, a common mistake that like object-oriented type of thinking will produce is something like, oh, we want to make this package format. And so there's an object, and it has all these methods dealing with the object. And like, for something like this, the use case is very different because like making a package is a messy process where you're doing a lot of heap operations and throwing a lot of data around and whatever. But the whole point of that is so that at load time, you have a very clean operation, right? You want a clean and simple load operation that is completely detached from all the messy creation operations. So we're going to do that in the API here, where it's just like, look, the create stuff is the mess and the load stuff is the clean, right? And even the create stuff, we're probably not even going to worry about, you know, doing too many heap allocations or something. I mean, we might worry about that later, but load is going to be very clean, right? Okay. So if we create a package, we need a data structure to hold this. I'm just going to call it create package. And we'll just call this one package, maybe. I don't know. We'll see. Can rename those at the drop of a hat. Okay, so we're going to create a package, and we're going to say we're going to have an init. Now, in this language, we generally do this thing where you have an init function for stuff. We don't really write constructors because the idea is you don't want to have to, like a lot of languages think as soon as you have something like this, you put it on the heap. We don't think that way. You might have an array of 1,000 of these stored flat in the array. And so you just call an init function on them to start them up, right? We have this dinit, which is a weird name, you know, but that's sort of what we landed on so far. We could put using here to make it act a little bit more like object-oriented. What are these going to do? I don't know. Maybe nothing. Actually, they'll do things. Now, what is in a package? Well, there's some data in the file, and then there's a table of contents. And that's generally how these things are modeled, and we're going to keep that. We're going to say there's a thing called, well, the data. And we already have a structure that's good for this. It's the string builder, right? To do that, we need to import. We're just going to import this at file scope globally, right? So that has string builder and a bunch of stuff in it. We might later want to configure the buffer size of the string builder, which is something that we can do. But for now, we're just going to leave it. We don't care. So I think down here we can say free buffers on data. And then we want entries here. So what do we call it? Like files or entries, let's just say entry info, and it's an array of these. And it's going to be a dot dot array because we're creating package, right? Who cares, right? And then we're going to say we're going to clear that array out when we de-init. To init, we don't really do anything right now. I don't know, right? So we're going to say create, add. I don't know. I was going to prefix everything with create, but we already didn't do that for init and de-init. So let's just not. Fuck it. Okay, so we're going to say add. File name is a string. And I don't know. This is where if we're going to do user data and stuff, we might think about adding that here, but we don't have such a thing yet. So we have the file name, and the data we're just going to say is an array of U8, just so that we could say it's a string. It's basically the same type, but I don't really want confusion between these two parameters. Okay. I'm not even going to have a remove or anything. Just like don't add something if you don't want it, please. We might add remove later. And then we're going to say write the package. Let's call this entry name, because like write is going to be, oh, you know what? We should put package, and we want to write returning a bool. And that's kind of it. That's sort of all I want. Maybe I'll figure out later that I want more. But that's sort of all I want, right? Let's do the write part first, the WRITE part. Why? Because we can just start doing that, right? Now, yeah. Okay. Oh, we want file name is a string. So here we're going to go header is a string builder. We're going to put some data in there. And we're going to have table of contents is also a string builder. We're going to put some data in there. And then we're going to say, do I have is it just in file? So we have file write with a string builder parameter, right? So we're just going to do this. We're going to say down here, when we write a file, we're going to say, first we're going to open the file, which we're not even checking yet. And we're going to say success header is file write file and header. We're going to say success body I mean, this always, yeah. I don't know. We'll just report errors for each piece. Log error in simple package, unable to write the header for file whatever, file name. And we're just going to do this every time. It looks like dumb, smooth brain code, but sometimes that's the best code. All right. You know what? Since I'm doing that, I don't need different names for this. Different names gives us a possibility to copy pasta error. Unable to write the body. And this way, if somebody has a weird bug and they have to step through their code, because these errors are different, they'll know where to set a breakpoint in whatever. Table of contents for file, whatever. Okay. Return true. Now, header data package dot data, and then table of contents. Okay. So that's easy. What goes in the header? Well, a magic number. We always like to put 4-byte magic numbers at the beginning of our file. And since this is the simple package format, I think our magic number has to be, something short and memorable. So magic number 32-bit integer, append header magic, right? Now we want offset to the table of contents. So we're going to write out the data and then the table of contents last. This is a trick that people use because if you want to append file to the format, which we're not going to do that right now, but if you want to append, then you just have to read the table of contents, write the new entries at the end, and then write the new table of contents, as opposed to writing out a whole new ginormous file, right? It's just a design decision that helps things out. So offset to the table of contents, 64-bit unsigned from the start of the file, 64-bit unsigned integer. So we're going to append, is it append? So we append string, append, so we have byte. Oh, okay. So I'm going to copy over a function that we have. Where did I put it? It's in serialize. So here's a polymorphic put function and okay, so this is just like, look, if you want to pass it a scalar, you can do that and it'll just do the mem copy right now. Why am I saying simple mem copy? That seems silly. Anyway, this is a whole endian issue. We're just, for now, it's a couple line change later, but we're just going to pretend that both the source and target machine are little endian, right? The file format is going to be defined as little endian. Is this, do I have this in a module? Is that why I can't find it? What is going on? Oh, it's in String Builder. What is this? Don't, unless you know the buffer has been initialized, there's enough space. We actually put a mem copy. That's like really not necessary. Let me just, no, you know what? Let's do this for now. And we'll go. Because, like, you don't need to do a memcopy here. I don't know why I did that. It's probably just the code evolved over time. We're just going to hard code this because in the compiler, we don't really have an official way of telling your program what this is. We could make this a module parameter. We're just not going to worry about it for now. Like, we're just going to do the basic thing, and then we can come back later. Need a way to change this based on target CPU. Oh my God, my tea's been steeping forever. Let's take care of that. Any questions about what I'm typing so far? Get some real good honey again. Medium endian is not a thing. Wait, I didn't put enough honey. I want more honey. I want maximum honey. Okay. Why are we putting some copy pasta in there? It's just, this is an easy way for me to put integers in the string builder. This probably should ship with string builder, but it doesn't right now. So like what we might do later to clean this up is just ship this with string builder, because it's like something that people probably want, right? What this says is like, look, if you want to pack like a 64-bit integer or a 32-bit float, then if you're little endian, because you probably should be little endian in your file formats, if you ship video games, that's especially true, because most of our target architectures are little endian. And what that means is if your file formats integers are the same as your target architecture's integers, you don't have to do anything to swap the bytes, right? You only have to do that on systems that don't match. And so you want to make that the minority of systems that you ship on and or the ones that are going to be slower, right? So if we assume our file format's little endian, then we can just drop these things into the buffer. But if it's not, or if we're not little endian, then we do something here. And that's why we have an incomplete, because I don't even have a big endian machine right now at all, period. But this would be, you would just put something here, right? Okay, and this definitely should be a static if at this point. Okay. First 2 to 4 bytes. No, we're not going to have variable endian in this file format. I don't think that's a good idea. Although we could, we could. Let's make a flags word. Okay. So here's what we're going to do. We're going to go flags word 32 bits. There are no flags currently, but if we wanted to designate an endian, we could have it be one of those flags later, right? Oh, actually, before this, you always want to put the version number, right? So we're going to put magic number, version number, file format version number, 32 bits, right? And this is going to be file version, right? And that is, of course, 1. So anytime you make a file format, just like be a little bit forward thinking, because the world is full of file formats that were not forward thinking, right? Okay, so flags words. Maybe later there will be an endian flag here. Like the endian thing is a little bit weird because there's like the endian of your package file format, and then there's the endian of like what's all the data in there. Right? What is big endian still, like PowerPC? Isn't ARM switchable endian? It's just almost everyone uses little. Anyway. Like the world is kind of converging on little endian over time, I think. Okay. So anyway, when we write the file, we're going to write out the magic number, the file version, the flags, offset to the table of contents, right? So put header cast U64 0. So we fill in 0 for now, and we will back patch it later. We actually, at this point, we actually know the offset to the table of contents if we are going to write as we go. So something that older code would tend to do is like you write this out as a 0 on disk, you write out all this other data, and then you go back and you fill in the number. And again, if we do this like more detailed version of the API, we might do that. You know, if we decide, oh, we're writing packages that are too big to hold in RAM. But for now, we're like, nah, these will all fit in RAM of a development machine. So we are actually going to be able to fill this in later. I just don't want to think about it yet. I want to get a file on disk, right? So we go file write the header, file write the data, file write the table of contents. Table of contents is currently empty. Here's what we'll do. Let's put table of contents. It'll start with number of files, 64-bit unsigned integer, right? So we're going to put into that string builder cast U64 of, what do we call it? Entries. Package.entries.count, right? And then for each entry, we're going to do something, but we don't know what that is yet because we don't have that data, right? Well, actually, we know there's at least... No, we'll not think about it yet, right? Okay. So then we do file write. And there we go. Well, this probably doesn't compile yet, but we'll see. And we want an example. We're going to make an example called create with an E, actually. Right, we're going to import simple package. We're going to import basic, right, main, right. We're going to have some strings. Item 1. Let's just do this. Item 1 is hello sailor, right. Item 2 is 10 floats. for 0 to item 2.count minus 1, item 2 it equals cast float, it times it. So we're just, I don't know, we're just squaring all those. What's a good third thing? I don't know, man. I feel like we've got to put 3 things. I kind of want to put a different data type and not just string ints. Let's have the floats be item 3. Let's have item 2 be a 100 U8 for we're just going to have those count up. This is item 3, right? The floats are going to be squared. Okay, whatever, right? We're going to do this. So now we're going to go, package is a create package, right? We're going to defer dinit package. We're going to init package, right? We're going to add package item run tree data item 1, right? We could actually just do this. We're going to add that. We're going to add this is item 2, and we're going to add package. I don't know. Item 3 unimaginatively. I don't know if I can do this cast implicitly. Let's see. So now we're going to write the package test.package. All right, cool. Let's not forget to add the thing. Okay, let's get a DOS shell over there. Okay, and then we're going to compile create. All right, number signage is mismatch. Yeah, because that's an S64. All right. File write. Oh, we didn't import file. Entry info. We never defined this. This is just going to be, I don't know. Well, it's going to be some data handed to us by the user, and offset from start of data. All right. It's going to at least have those things. File write. Really? File write. I thought I imported file. Oh, I didn't import it here. File write file. Oh, we never opened the file. If you want to succeed in the game industry, open the file. Open the file. Okay. File open. And we're not even going to defer close. Oh, yeah, we are. Okay. File open. File name. True. False. True. Success. Oh, file success. Colon equals, right? If no success, log error in simple package, unable to open whatever for writing. File name, return false. Okay. These maybe should be flags eventually, I feel like, but they're not. Okay, so we now have a file. We're going to defer file close file. File right. Yes, 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 yes. Yes, 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 yes. Oh, all these. All these. Okay, create. Boom. Dir. Test.package, 28 bytes. We have succeeded in the games industry. Kinda. Little premature to declare that, I admit, but simple package, examples, test.package, simp, a, it's a simp, and then zeros for all the other things. That's great. That is great. How's it going, everybody? Have you succeeded? Have you succeeded? I have. Okay, but you'll note now our example, our package here doesn't have any data in it, right? Let's delete other examples because we're not delete them, but clear them out of Emacs so we can get to this one faster. Yeah. Oh, wait. Oh, it's called create. Okay. And we actually spelled create with an E. Let me tell you. Let me tell you. Okay. So we're adding these things, but we're not really, right? So let's really do that. Module. Oh, we've got so many modules open. So many modules open. Simp. I want to at least autocomplete simp, so let me close that one. Okay. So when we add, what happens? We're going to say entry is package array add to package.entries, right? Entry dot data equals data, and then we're not even gonna we don't compute offset from start of data here because we want to allow for the user to sort the entries. Now there's a weird thing because maybe you want to sort the table of contents differently from the entries. I don't know how I feel about that, but maybe we want, like from the actual data, right? Maybe we want to allow for the user to sort the entries after they're all added prior to writing. Okay, that's just going to be the way that this works. So we add the entries. Now, when we write, remember when I said we're going to do this? We actually want 2 for loops over the entries, right? So one of them adds the data. You know, we don't actually need that data string builder because we're just going to write these entries out right here, right? We're going to say for every entry, we're going to have some offset and I'm going to keep it offset from start of data because I know how big the header is here. No, you know what? Let's just put offset. Offset from start of file. if we want to change that back, I was going to like add the header size to the offset later or something, and we're not going to do that. Okay. That's going to start at 0, and we're going to say, actually, it's not going to start at 0. I just literally said, how do I get the length in the string builder? Builder string length. Okay, for every entry, we're going to say file write, file cast string. We're going to say success is that cast string entry.data. And we're going to say if not success, log error in simple package. Oh, you know what? Each entry is going to need a file name as well. And we can put that in the error message. Unable to write entry number something with the name to the file, right? And this is going to be it index +1 and entry dot name, and we're going to return false. From there, yeah, we need a name here, right? And when we add the entry, we're going to be like that. Entry name must remain valid until after write is called. Okay, we're just going to let you have memory responsibility over that entry name, which some programmers might find scary, but that's the kind of thing we do in this language. Okay. Now, so we do the file write, and then we say offset from start of file plus equals cast U64, entry data count. There we go. That gives us the table of contents. Okay, yeah, this was sort of would have been like we could do 2 packages over the entries to get where the offset of the table of contents is going to be. We'll deal with that later. You know what? Also, should we put something in the file format that there's a 32-bit magic number at the table of contents? Because whenever I'm writing file format code, that's the really annoying part, is like, oh shit, the offset's wrong. Right? Let's even do that. Let's just fucking do it. Special magic number to help you know you hit the table of contents. Table of contents magic is going to be that. So, I mean, you maybe don't want to scan through the file for that because you might get a false positive, but it'll just help you know, right? So we're going to put table of contents, append 32-bit integer. All right, number of files, right? And then here, for each file, let's put the file name first. The file name with a 4-byte with a 4-byte length prefix followed by, see, we're not going to try to squeeze these down like too small. You could probably get away with 2 for almost everybody, but like, like why? It's just 2 bytes, right? I don't know. We'll see if we regret that. We can always have a bit in the header for smaller string lengths. For each file, the file name with a 4-byte length prefix. Okay, wait. Let's say it in the order that it is. A 4-byte unsigned integer indicating the length of the file name, followed by the file name, non-zero terminated. Actually, let's do it 0 terminated for the C people. The aforementioned length does not contain the 0. That might be a little confusing for people working with this format. But you know, they can deal, hopefully. Because you just want to be able to do it either way. For C people, you want to just be able to point into the file and let them use that string if they want, right? Okay, followed by an 8-byte integer indicating the size of the data entry, followed by an 8-byte integer indicating the offset of the entry from the start of the file. Like, wow, you know, it's already a lot of bytes per entry. But, you know, we can trim that later if we want. Could use variable length integers. I thought about that. We could toy with that idea later. I'm not sure I want that complexity. But it is true that for most of these you could do, like, what is the simplest variable length integer? It's something like the UTF-8 thing, right? Where it's like, if the high bit is set, there's another byte. Otherwise there isn't. And you just put 7 bits at a time into the number. The thing is, that might be like slow to decode. I don't know. We could think about that later. Like, we're just doing the dead ass simplest thing for now. And we'll see. Okay, so for every entry, we're going to say if entry.name.count is greater than that log error or entry.name.count is less than 0, log error in simple package.write, the count field of entry, whatever. We're not going to try to print the name because it's freaking corrupted. Is too long or corrupted. Maximum length is the highest 32-bit unsigned integer. Let's just say that. Return false. All right. So we're not going to be super paranoid, but we're just putting in a little bit. Like, look, sometimes when you're developing a game, you trash memory somehow, and we're just helping you out if you trash your own memory, right? We certainly expect you to pass well-formed entries in here all the time. Okay, so that's so put table of contents cast U32 to entry.name.count, right? And then append entry.name.data, entry.name.count, and we're going to put a 0 at the end. Put cast U8 0. That's our 0 termination. And now we put the size, right? Put table of contents cast U64 package.data.count, right? And then the offset, what did we call it? Offset from start of file. Oh, sorry, entry.data.count and entry.offset from start of file. Okay. Is this what we said? Let's double check. So a 4-byte unsigned integer indicating the length of the file name. 4-byte unsigned integer. Followed by the file name. 0 terminated. The aforementioned length does not contain the 0. That's this. And this. So this is just the pointer to the string data, and this is the number of bytes. This is like a C-style string append. And then 8-byte size of the data entry, and then 8-byte offset from start of the file. Okay. So we file write the table of contents at the end. Now we're not backpatching in yet. I think we're going to pre-compute it as opposed to backpatching it because I think we would like to single pass the file. But let's just, whoops, I compiled the wrong thing. I'm just so in the habit of building the game. All right, so builder string length. Right. Let's just do this. Incorrect number of requires 1 argument. So it's talking about the number of percents. You see, I didn't add any print values in there. And even though this is a user generated or a user built function, the compiler, you know, the static, we have a whole metaprogramming system that lets you program in checks for stuff like this, and it saved my butt here, right? Because I forgot it index +1 right there. Okay, so I'm going to run create with an E, and now we're going to go back and look at our test package. Notice it's bigger now. And if we load it, it's like, here's all the data that we put. There's a table of contents. There's the, there's those. Okay, so now it doesn't have offset to the table. This is a bunch of zeros still, you'll note. But apart from that, it looks like a functioning package format. Right? Right. And we're not remotely done yet, but this is fine. Okay, so now we're going to pre-crime the offset. In fact, you know what? We don't actually write this to the entry, I'm noticing here. I hope somebody in chat noticed this. Lol. Lol. Okay. Now though, we want to break this loop out anyway. So we're going to up here after we open, or no, before we even open the file, we're going to do this, and we're going to comment this. So down here, we're not going to set these. We're not going to set this. Actually, here's what we're going to do. We're going to assert that the number of bytes we put in is already known. And then for each of these, we're going to say offset plus equals entry data count, right? We're going to assert offset is equal to entry dot whatever this was called, right? So that if we screw up, we'll know it. right? Very important to do this in your programs because, you know, often you might not screw up, especially as you get more and more experience, but at some point you will. And this will save you time. And it's self-documenting, right? It's like, okay, there's this value stored there that we need to match. Okay. So this is all very good. Are these packages used to load level data or save game data? This system is intended only for data that you ship with your game that is effectively read-only during gameplay. Okay. Of which, I mean, that's almost the entire footprint of every video game is read-only data. That's what this is for. And because it's read-only data, like, you can make a great deal of simplifications around it, right? And that's how you get performance in a video game. Okay, so what we're going to do is we're going to define this known header size. And how big is that? It's 4 bytes, 8, 12, 20 bytes. Okay. We can document this later or something, but known header size. All right. And now we're going to say pre-pass compute the offset from the start of the file of each entry. Then we know where the table of contents will start. It's after all the entry data. So we can just write that into the header and not touch the file a second time. Okay, so here, boom. So that's our pre-pass. And now, offset from start of file. Wait, do I still have this in my buffer? Emacs. Emacs, there we go. Emacs finally came in handy. All right. Offset from start of file. Okay, so this should write out the same amount of data as before, but like some things are filled in that were not. Oh, can't assign to a large value. Oh, yeah. Okay, we're writing to entry, so we need to take pointers. Number signed is mismatch. Wait, oh, yeah. We're signed by default. Same there. Same there. Maybe I should have kept this signed so we don't have to do these casts. Whatever. All right. Boom. And then test package, still 1 KB. Look, we've got numbers in here now, and probably also here where there were a lot of zeros before. That's great. So we now can write a package. Next, we read a package. And honestly, it's not going to be that different. I mean, it's not going to have the string builder, though, right? Okay. Here's what we're going to do. We're going to say we have a create package. I mean, this might be parameterized with like buffer sizes and stuff. Who knows? This is probably going to get more involved. All right. A load package. is going to be down here. Let's call it load package. That might be a little verbose, but it contrasts it against create package, right? So you at least know that they're kind of two different things. What is this going to be? Well, it's going to be the data of the package. And we're just going to parse out the header. You know, we could have like actually filled this out and written it in binary, assuming little endian, right? Maybe that would have been the thing. But I maybe would like, I don't know, because sometimes it's just simpler. What do you guys think? Like, what if this is just supposed to match the file byte for byte with endian swap? Is that a good idea? It doesn't matter right now, actually, but we could do it on load, and then no check-in, just use package header maybe, because that would simplify all this stuff. Like known header size would be, etc. Struct padding is not an issue. You have control over that in this language, or if you don't, we'll add it. I've got to keep oscillating the temperature in my room. It claims it is 62 degrees in here and is a liar. I don't know what's going on with them. Okay, so let's just say magic is a U32, version is a U32, flags is a U32, right? And then table of contents offset is a U64. Right? And let's just say right now, let's put this here. And we're going to assert size of package header is equal to known header size. All right. Compile time assertion failed. What? 8? 12. Oh, this is padded, right? So yeah, that's the question. Do I have the ability to remove the padding here right now? We can. Okay. This is gross. By the way, it's an internal debate, or not even a debate, but it's an internal discussion whether we should pad at all right now. Like right now we pad to match C, but I don't know. It's probably not a good idea. This is a gross thing we are doing to put the thing in the right place. And that is going to be junk is U32, place to junk, right? So we're just saying put it where this would go. That's kind of a hacky way to do it. Oh, it's still not working. Really? What? Run, print, size, whatever. Maybe place is happening before alignment. Size 24. Dude. Hey, guess what? We're not going to do it this way, but we might do it this way because this is just a simplification. I do think we don't seem to be able to control. Wait, one more try. Can I do that? Dang it. Where did I put a... See, I almost never use this. Is this on a struct? Let's look in the compiler here. Align directive. It's on declarations. It's after. Why did I put it after? Like so many things are before. Size 20. All right, cool. So that's better than the gross thing that we were going to do anyway. Avoid padding on this member. Okay, I redeemed myself. It's fine. It's fine. All right. Won't it put it correctly if you just keep junk? Why even align? Well, see, it's order of operations. Like I think it's when I put the place. See, I want it where junk was, and I don't think that's actually possible right now using place because like place puts you somewhere and then alignment happens after that, which doesn't seem good to me, but it's like not really an issue that we'd come up before. I think place should override default alignment probably. Let me write that down. Keep a reserved field. Yeah, you know what? Like, who cares about the header size, right? And maybe someone's gonna care. And you know what? You can always maybe use that field, right? It's yeah, okay, we'll just do that. Good idea. Reserved U32. We're gonna be 24. Okay, this is as big as the header can ever get, everybody, because it's now 24. All right. Known header size. So now we have to reserved write a 0. Like people always want more space, man. Plus, I do think I want to use that for user data size. I want to use at least 1 or 2 bytes of that. So maybe we should we reserve like 2 more 64s, or like maybe that could just be a version update. I don't know. Fuck it, let's do it. That way we have room for growth without having to bump the version. Or like it's yeah, okay. We would bump the version if we started using that anyway, but like it would be less to worry about. So it's 40. I mean, we could make it an even 64. Right? Wait, that's 56. Yeah, 64 bytes is enough for anybody, right? Okay, let's make sure we got this right. 1, 2, 3, 4, 5, 6, 7, 8. 64 bytes. All right. Cool. Cool. Great. Oh, yeah. You know what? Reserved 0. 1, 2, 3. Right? There we go. See, assertions are your buddy. You don't want to fumble around like a scheme programmer trying to figure out what the fuck is wrong for 6 hours, right? You just want to know. All right, so this is all good. I mean, it's time to start reading it, right? Okay, so load package. We're going to say, now again, we're going to assume that you have the memory for this. This isn't going to be a new package on the heap thing, at least not for the package header struct. Like the data we're going to load, and you could probably override the allocator before calling load if you want to. So we're just not going to worry about any of that right now. So we're going to say load. We could also later make a yeah, okay. So actually, one thing that you always end up wanting is like init from memory, right? And load is just going to call this, right? We're going to say init from memory, the package, right? And return true. We could actually return from here because it'll like check the magic number and stuff. So for now, we're going to assert target is little endian. We can endian swap the header later. Okay, so we load the package. Data success is read entire file. We need the file name, right? File name. If not success, log error. Simple package.load failed to load file name, whatever. Okay, return false. Great. We init from memory and return result because that might return false. Okay, the reason we split it up this way is because often you just have some memory that you got by other means. And maybe maybe you want to put a package in your package because you heard you like packages. Like I don't even know what, right? All right, so init from memory. Let's just say if data.count is less than known header size, return false. Too small. We could even do an error here. Log error. Package. We could pass the file name as well. Name for debugging. And, maybe people don't pass that. Package whatever is too small to even contain a header. It's whatever bytes. Whatever name for debugging, data.count. Any help that you give people in debugging will pay back tremendously if even 100 people use your thing, which is a small number. Putting in stuff like this that tells them what is wrong. You don't just return fucking false, right? You tell them what is wrong. It helps so much. It helps so you're saving people's lives. Okay. Right, so now we're just going to go header right? And then we're just going to cast that pointer, and then we're just going to say package dot header equals underscore header. Now, if package header magic, let's do this. Using package dot header, if magic is not equal to magic, all right, we're just going to check all sorts of things right here and tell people what's going on. Log error, package, whatever, has an incorrect magic number, wanted whatever, got whatever. And then we'll go format int, magic base equals 16, format int magic base equals 16. I mean, we could have hard coded it, but you know, return false. Okay. If version is greater than file version, log error has an invalid version number or a version created by code that is newer than we are, so we don't understand the format. Its version is whatever. Our highest known version is whatever, comma, name for debugging. Oh, I forgot to put name for debugging up here. Hope somebody in chat caught that. All right. Name for debugging, version, file version. Okay. Or it's unsigned, so we don't check less than 0. Okay. What else? We check that the table of contents where are we? Package header. Table of contents offset. If table of contents offset is greater than or equal to, because if it's equal to the file size, there ain't nowhere for the data to go. Okay, log error, package, whatever, has an invalid table of contents offset. We'll just name the variable what it is. It claims to be whatever, but the file is only whatever bytes long, right? Name for debugging, table of contents offset data.count. Okay, so that's just some checking that we do. Now what? Well, we're going to cast to, well, we're going to do that. Oh, you know what? We can check that magic. Right, because we had table of contents magic. So should I do this with a struct again, is the question. Boy, I've drank a lot of tea. I kind of want more, but I kind of don't because it's going to get late. So my two options are I make a little struct or I copy the little get function like we had this put function. And I might be tempted to do the struct, except that one of the things that I was talking about was having flexible user data per table of content entry. We haven't added that yet. But what I would like is like when you start the file, you say, hey man, here's some extra data, right? You know what though? That just means that can't be included in the struct for a per entry, but that's even different than what we're talking about. What we're talking about is like the table of contents struct, right? So we're just gonna make a thing for that. Let's get rid of this. So the table of contents struct has table of contents magic, package.entries.count, that's it. We could also put some reserveds in there though, right? Isn't that a good idea? How about if we pad that to 64 bits? Or 64 bytes, sorry. Just like the header. We can call this Mega 64 is the name of the package format because everything is 64 bits. Table of contents is a struct where we go table of contents magic. I'm not going to just say magic again because, you know, we could even okay. So, and then number of entries is U64. Okay. Oh, this is kind of what the simple memcopy is. Anyway, I mean, that's what I made it for. Okay. Cool. Problem. These magic numbers are actually strings right now. And if we want to do the header thing, I mean, I could do, yeah. I like defining them as strings that way. We could use a run directive to like write it as a string but convert it. But like, I don't know if that's worth it. You know. Okay, let's do this. Let's not. I was getting schmancy here. This is actually a little bit. Let's just not do that. It's a little bit presumptuous. All right, so here we're gonna go. Contents is table of contents, right? Contents dot table of contents magic equals, and this is going to be right. Endian, need to endian. So actually, instead of putting @endian, we're going to put assert. Where's my endian assertion? Yeah, we're just going to do this. That's just a reminder, and if we miss some of these, then there we go. Okay, so we've got a table of contents. The magic is going to be I mean, I could make a macro for this. This is gross. We're just going to write it out. Kind of gross. No, you know what? Let's use a run directive for this. And like, let's just make the compiler fast, right? Right. That's okay. This is the policy. This is the policy, is just I mean, right? And we'll just okay. The number of entries is this, and then we're going to make a little helper. Whoops. We're going to make a little helper called append struct builder contents, right? Well, what is that? It's just going to be. See, this is weird because it's like this simple mem copy, but like I don't know why this didn't ensure the space. Right? Anyway, let's just do our own version here because I don't this feels to me like a little bit the wrong place. So we call ensure contiguous space. Okay, so append struct builder is a pointer to string builder. Contents is some struct or to append. All right. Now ensure contiguous space builder size of t. All right. Assert pointer not equal to null. Like if you couldn't ensure that, something really bad happened, right? If pointer then mem copy pointer to append size of t. That's it. Like this looks cleaner and less messy than that string builder one that I just did. Okay. We probably don't compile anymore. Let's make sure we do append. No? Oh yeah, it's not called builder because we have head table of contents. Table of contents. Okay. While we're at this, let's just go do this as well with the header. And we're going to say header is a, H is a package header, right? And we're gonna do that, but we're gonna go header.magic is magic, header.version is file version, right? Whoops. We don't need set flags or any of this. We need to set, well, we don't fill in 0 for now. All right. Whoops, I deleted my pack struct call. So we delete all this. Append struct header H. Oh no, table of content. No, header. Yeah. Yeah. Then we open the file. We write the header, etc. Okay, so, whoa, I said header dot instead of H dot. Silly me. All right. Assertion failed, line 71. Offset is known header size. Ooh. We don't actually print the value. Did I mess up? Because we know the size is right. Is my append struct messed up? Like what? Offset is 0. Really? Oh, because, oh God, guys. Guys. What? We don't even need to ensure contiguous space anyway. What am I even doing? We just go append builder because we're going to write this out. Okay, my brain was in a different place and we're bringing it back. We're just going to append builder to append size of t. That's all. We don't even need it to be contiguous. What? So the problem there was I was doing the mem copy, but I wasn't advancing the size. All right. Append to, right. So we need to cast pointer U8 that. Okay. Great. Great. So if we pull our package in, hopefully it's not messed up again. Yeah, okay, we see the A here. We see a lot more reserved bytes. That's why there's more zeros. But it looks like I see the data. I see the datas. All right. So now let's go back to reading. I just wanted to change the writing out to make it a little simpler here. So we're going back to reading. When we're going to load the dude, we say read entire file. We init from memory the package. All right. So here we say talk start. Oh, yeah. That's where we were. Table. Okay. So we're going to say talk is cast table of contents. This. Okay. So, and here, we just want to guarantee that there's enough space. So now we know we can do this safely, right? So if talk.table of you know what? Let's just, no, okay. Log error, we skipped to the supposed table of contents. Okay, in package, whatever. We skipped to the supposed table of contents at offset, whatever, but did not find the magic number there that we expected to find. We wanted whatever, but got whatever. Okay, name for debugging. Let's just give this a real short name. So we can use it again. Name for debugging, offset, table of contents magic, talk.table of contents magic, but we're gonna go base equals 16. Format int. Format int. All right. Return false. Okay. Now we're not gonna try to bulletproof the number of entries. Like if this is totally corrupted, we have some corruption protection in that if we went to the wrong place for some reason, we won't have seen the magic number. If we do see the magic number, we expect this number after it to be reasonable. Okay, anyway. Actually, we could make another struct for the entry, right? Because that's what we would start looking for here. And it's like, oh, let's make sure we have enough space and whatever, right? Yep. Let's make sure we compile still. We parsed a declaration. Oh, well, we use semicolons every day. I wrote numer. Oh, dude, this function isn't getting called, so we didn't notice that because it's lazy. Let's go to our, let's go to here and let's have a write package and a read package. Right. Write package, file name, and read package. Okay. So this is our little program. It's not 50,000 lines long like Microsoft sample code, written by the summer intern. And we're going to read the package. What do we say? Well, we say load package, right? That's a package. We're going to say init from file, right? Let's say init from file, init from memory, right? That was what I impulsively did. Package, so success is this, right? File name. If not success returns, someone will have printed an error. And then this is going to be create entry info. We literally, wait. Yeah, we literally never use it, but right there. So that's fine. And we're going to have like a load entry info. Or should we? Actually, no, because you're going to want, like, so far there's no reason to make them different. Like, you might want this information. Okay. So, load package. Table of contents is a table of contents, right? And entries is going to be an array of entry info. All right, so here we're going to say print package has whatever entries. Now we don't know what's in them yet, but we're going to print that. And here we want to set this. So init from memory is going to say, okay, and then return true probably. Okay. Mismatching levels of indirection. Array resize. Oh, because it's, yeah. I should have used S64, dude. We're not going to change it right now, but come on. All right. Entries is not a member of table of no, not talk.entries. Package. Did we call it package? Yes. All right. Create with an E. We skipped to the table of contents at offset 188, but did not find the magic number there that we expected to find. We wanted 74. Okay, I fucked up the magic number. And it also shouldn't be 0. The magic number is not 74. Bruh. Like, I guess we could probably const evaluate this eventually, but I don't think we do currently. Okay. That looks like a better magic number, but we did not find it at offset 188. I suppose we could use the hex mode here. So this is frickin' hex. All right. 188 divided by 16 is 11.75. I don't know. I don't know what that is. Let's just ask. Okay, here actually. So 21636F74. 21636F74. Okay. That's fine. It's probably at the wrong offset though. Can Emacs tell me what the offset is? How do I know? B something. So 188. Does this do hex? It's got to do hex, right? Programmer. Oh, of course it clears all the numbers. BC's quest for tires. C, D, E, F. Yeah. So it's in the right place. So the loading code is messed up. The loading code is messed up. So let's just print out the whole thing, first of all. Oh, shit. Guys, do you see what's wrong? Do you see what's wrong? This would be fine if we did not copy C conventions for pointer addition, but we did, so we went way too far. Package has 3 entries. Revert buffer. Oh, God. This is completely unusable mode. All right. Very good. I kind of feel like now is a good 5-minute brain break. So the next thing that we're going to do is parse out the entries, but I want to get a drink out of the fridge. Any questions on what we are doing so far? So far, simple package format. There's the package. There's the package with some datas, with a little face. It's a little nose, crooked nose. How many years did it take me to get to the level of programmer I am right now? I've been programming since the age of 10, and my actual age is a secret, but it's 50. So I've been programming for 40 years. Sag. I'm likely still improving, but I assume not at the same rate. I mean, I've been in the beginning, you improve really rapidly, right? Because you don't know anything. But I don't know, my rate of improvement is still noticeable to me. I am definitely better than I was 5 years ago, clearly. Yeah, I don't know. On topic questions, though, please. On topic questions. Turning 50 the day after you turn 20 is rough. I know, man. There's some pretty bad symptoms to some viruses going around. They'll do a number on you. What's the point in reserving if you'll have to bump the version number anyway? Because then people who use the file format don't have to adjust. You know, you're like letting their code work. What do I think of human readable package storage formats? Why? What? 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 Name one. Use your string builder strictly for building UTF strings? No, you can think of it more just as a buffer composition thing. It is not only UTF-8. Like we're using it for binary data here. Like you could put binary data in these packages. It's fine. Okay. Now, is it hard to switch between so many projects? Yes. Yes, it is. Yes, it is difficult. I think the optimal number of projects for me is 2, like a main one and then a side one that I can do when I want a little bit of relaxation from grinding on the main one. More than 2, not good for me. Okay. So we're doing all these entries and well, I could kind of do this. Yeah, okay, so let's go back. We have our per entry. You know, it's funny. Way back, I forget if it was for zip files that I saw this first or like PE files or something, but I saw some Microsoft storage format or something, and I was like, it's so gross to just write all the structs to disk like that. Like, that's not portable. I'm much more enlightened. I'm going to do a thing where I like pack things byte by byte and make sure they come out correctly. And you don't even need to define the endian based on your platform because I used bit shifts to compose all the integers and stuff. And like, that was in the 90s in my first game studio. And now I do it exactly the way that I saw, except my variables are named more readably. So like, it's come full circle on this issue. Because there's not really anything unportable about doing it this way as long as you can control your structs, right? Okay. Maybe it was zip files. Yeah, I don't know. I don't know, man. Okay, so we have a table of contents. I'm just going to say entry. You know, I'm not going to say table of contents entry, whatever. It'll be namespaced in here, right? So, oh, but we can't. See, See, it's a variable number of bytes. How many lines? We're at 260. That's not too bad. So for each entry, we write the name first. I feel like that's because people just want to check the name. Yeah, you know what? We're not going to try to write this out with this struct. This struct is just going to be for the user. I fight for the user. Okay, so name is a string. Points into the file. 0 terminated if you want to pass .data to C. Data size in bytes is a U64. Data offset from start of file is a U64. Right? And then, like I said, maybe later we add some user specific thing. Okay. But now when we load this, we're going to say I'm going to use get. Since let's get my get. This is the analogous to put, right? We're just going to put this down here. And like I said, we might ship that to string builder. Okay, so we just say get from a string and pointer to some type. And we just handle that for all the primitive types. So we're going to say where were we? I'm in the wrong file again. That's why I'm confused. So here's where we were. So we want to put name length is a U32. We want to get name, or sorry, from S, which is, we're going to say what that is in a minute. We get the name length, right? And then if s.count is less than name length plus 1 plus 16 is for the chunk size and offset. I could call them chunks because that's like what other formats do sometimes. Who knows? Not worried about that yet. Okay, log error entry whatever is too short. Table of contents entry whatever is too short. Index plus 1, return false. Fine. Okay, so we're going to have chunk size U64, chunk offset U64, right? And we're going to get S chunk size and offset. Now, okay. So what is S? S is going to be a string s.data equals data.data plus offset plus known table of content size, right? S.count equals however much there is in the file, right? Data.count minus this. Assert s.count is greater than or equal to 0. Okay. Let's just check at the head here each time. We could maybe optimize this later anyway. Don't care right now. Okay. So we're getting the name, we're getting the other stuff. Now, let's just say entry is entries sub it index. Entry.name initialize this up here. The name is going to point to s.data. Entry.count is name length. All right. We're just pointing to this name in the middle of the data, right? This actually can just be entry dot whatever, right? Type mismatch. I really should have made him signed, guys. It would have been much less casting. We'll do it. We'll do that on a cleanup pass later. It in what? Oh yeah. Okay. Okay. Maybe in integer iterations like this, I should just have it index be an alias for it. Then you wouldn't have to think about it. You know what I'm saying? 228. Yeah. S. Okay. I got it a little bit wrong there. Chunk size is not, oh yeah, it's not called chunk size. Wait, okay, so first of all, I said I wasn't gonna do this, and then I frickin'... Okay, so we set the name. Okay, we're gonna do this a little different. Entry.data is, or entry.data.data is the start of the file. What? This is gonna get confusing because that's called data. There's so many datas right now. Data.data plus entry.offset from start of file. Entry.count equals chunk size. Yeah, so okay, hold on. Let's just do this again. Let's just do that. We get those. Now, let's actually range check this for the people, though. All right. If chunk offset is greater than or equal to the start of the table of contents. Log error. The chunk start offset. The chunk start offset for we're calling them entries. The offset from start of file for entry whatever is out of range. It must be before the table of contents, which starts at whatever. All right, chunk offset. But it was whatever. All right, so chunk offset is the third. This is the second, and it plus 1. Okay. Turn false. All right, so this all seems good. Yeah, we might rename entries to chunks later because Zip or whatever calls them that. Also the Goonies. Chunk size. Entry dot count. One S64 given, yeah. So much casting, we're going to have to get rid of that. Okay. Package has 3 entries, but now we can say what they are. For package.entries, print whatever, it index it. Oh, we won't print the whole array if it's beyond, but we're literally printing the bytes. So have fun with that. This is 0.0, this is 1.0. Wait. Not sure that that's right. What we're printing there. Offset from start of file seems kind of reasonable. This doesn't though. This is supposed to be longer. We might be storing that wrong because it's 10 float. Item 2. Item 3. You know what? This cast, okay, this cast does not, we casted this to 10 characters, not 40 characters. I'm not sure that's good. We're going to want to think about this. Well, I don't like all that. Hey, okay, that looks better. So now, when you load this, you probably have someone asking you, what's your job? And you have to say, tables. Tables. All right. Tables. So we're going to populate a table that maps names to pointers to entry info. And we might change this later, right? This is loading code, so it doesn't affect the format. Anyway, so our load package is going to have table, which is a table mapping string to pointer to entry info. I mean, it's weird because we'll call it lookup. I don't know. All right, so import hash table. So we want to build this table. So for all of these entries, that we load, we're going to go table add lookup package.lookup entry.name entry, just like that. Okay, so now we can say back in our program, entry found is table find. Oh, let's return the package. Ugh. From the reading, sorry. Now, this is a language where we treat stuff as what C++ thinks of as pod or whatever, even when they so-called own memory. So we just do this, and in C++, you would have to write a ton of like move constructors and stuff. And here you don't do any of that. You just return the value just like you would in C, actually. Except it's faster here because it doesn't do the stack thing that C does. Okay, so we're going to go package is read package. Oh, let's put success first. Always put, I don't know. All right, so all right. Success, comma, package. If success, entry found is table found, table find, package.lookup. This is item 2. If found, print found the entry, entry dot, actually, just that, else print did not find the entry, oops. And we'll assert false because this can be a test later. Yeah, else assert false, etc. Okay. Table find, oh boy. Import hash table. Great. Found, oh, wait. What? So we return true. Read package, return success. Oh, yeah. It just, we were printing out such a big goober field of stuff. All right. So, I mean, I think it basically works. Like, what else do you want? When the first line of read package shadow the parameter. Returns don't have scopage like that. In Pascal or something, you could assign to the return value. I might think about doing that at some point because sometimes I do kind of feel like it. But here, yeah, these don't, yeah. In fact, it's a little bit self-documenting to sort of say that this corresponds to that a little bit. Okay. Well, you know what? I'm just going to rename this example and not create because it also reads now. And I'm going to check this in. Is there any no check-ins in this file? Just that. All right. Well, we can tell the people that added modules simple package a system for writing and loading read-only packages to hold game assets. Okay. Anyway, add simple package. Boom. Dang it. People are working on the compiler. Oh, that was me. Probably. Oh, and Raphael also. Okay, well, you know. Okay, cool. Cool. Now what? Well, we start to use it in the packager. Let's think about this. I was saying before, you know, I had sort of done this vertex paint example that says read entire file from disk or package. This isn't going to save us a ton of stuff, but it'll save us, you know, 700 files or whatever we saw, right? Whoops. Like vertex paints are these. I don't actually know. This may not be. I kind of almost want an example with more files. The easiest one, which is the textures, is a little bit big. I could break it into multiple packages. I still don't know if we want to load. It's like 3 gigs. I don't know if we want to load that at startup. Meshes, like levels would be the best thing, but I'm just not sure. No, we could do that. I mean, probably what happens in the final game is we have some number of zones and whatever. So the thing is, if I don't make this be the packaged thing, then I have to change this line back. Let's do the entities because it's obvious when the entities work, because if they don't work, nothing will load, right? Whereas paint data, it's like we have to look at the different scenes for a while and be like, you know. So we're just going to leave this so that it's easy to switch back to this later. Okay. Let's put this into the packages file. Okay, this is something I didn't think about, but maybe we don't always want to make that hash table. I'm not going to worry about it yet, but maybe we don't always want to make a hash table for each package if we are just going to load multiple packages. Doesn't matter. All I'm looking to do right now is get this working for one package. Then I could go to bed, and then later we can make our game handle multiple packages. So let's go to the package program, right? This is different. This is not in the game, right? We're going to import simple package here. And when we see an entities file, we're going to put it in the entities package. I'm going to say package underscore, let's call it levels. You know what? It could have the level sets. We'll start by just putting the entities, but it could have the level sets as well, because those could just all be loaded globally, I think, and there's no worry about it. Maybe. All this can change later. Package levels is a load package, right? No, it's a create package. What am I even doing? Okay. Now, when we get to the end, we are going to want to say write out the packages. We're going to say write the, what did I call it? Package levels. Package levels. Okay. So our init really doesn't do anything. We might want to remove this. It's easy enough if there needs to be an init to call init on the first add or whatever. It's just an extra if statement. It's a little bit wasteful, but Okay. So we're going to init package levels. When we write that, we need to say what it is. Join target folder, run tree data. It's just going to be right here. Levels.package, right? Okay. What's in package levels? Well, okay. Here, so it's a little bit of a question. Where do we put this? I don't think we do it in the visitor. We could, but let's just see. For everything that we found, if if the extension is .entities, like we could generalize this later about having arrays of packages with extensions and stuff. We're actually going to just do that anyway. We're going to call it copied, right? Put file into package, source package levels. All right. So put file into package. This is going to be single threaded for now, but you could imagine dispatching this to a thread that like does the thing. Where do we put it? I don't know. Put file into package. File name is a string, and package is a create package. Well, data success is read entire file name. If name not success, log error, unable to open file, whatever, input file into package, file name, exit error, I think I say, right? Otherwise, add package. Oh, we kind of want the short name. Name data. And then we're just not even going to free the data. Like the theory right now is that, like I said, we can hold everything in memory. That is just at the end of the run anyway. So do we care? It's like the only time that we really can free this is when we're about to exit, because like we do this traversal of the file system to grab all these files, but like we don't know if there's going to be more files for this package or not at any given time until we know that we're done with all the files, at least the way that it works right now. So there's not really a like, oh, let's write this package out and free the memory scenario. Okay, so now we want the short name. I think path has a base name. I don't use this enough yet. Let's see. And this is, oh, whoops. What am I even doing? Into package. Base name is a string. And remember, this name has to stick around. That was a thing that I said. And so does the data. And the bones are their money. Okay. Let's just explicitly cast. That's more self-documenting, I guess. Extension is not a member of path. Really? Really? There's literally, we don't, I'm sure we have it. Oh, this is the part that wanted the extension anyway. Whoops. So what is found? Find result. It's just an array of strings. I didn't save the extension. All right. T. Let's just do this. Whatevs, man. Okay, path.base name. You know, where is this? No. I'm starting to get tired, folks. I don't remember anything anymore. Yeah. Path dec. It wasn't even in there. Path decomp. Right, where is that? It's just in string. Okay, so path decomp. Path base name extension, right? Yeah, let's just use that. I end up using this a lot. This more structured path thing was supposed to be something that I want to use, but I kind of don't right now. So that inspires some reflection about whether it's actually the right thing. 118. Okay. No, path decomp. This is really silly. I mean, I really should do this. You know, maybe I should make a function with this same API that just operates on this path thing, because it like has all the pieces between the slashes like broken out into an array and all that. Oh God, let's see what happens. I might have screwed it up bad. Oh, do we have to close a folder? Maybe not. Oh, we did. How come I never can find the folder and then it does it? I should actually say when we're writing out a package. I should count. I should count how many go into a package, right? And all that. We don't care about that yet, though. Okay. So we didn't error, interestingly. Let's see if it's there. Scripts, dist, run tree, data, levels.package. Oh, it's only 1K. Bro, there's nothing in there. Really? Really? All that, and I just didn't add anything to the package. We know that adding things to the package works because our example did it. Oh, you know what? I bet it's this. Right. let's just do this for a second, which is really gross, but whoops, let's recompile. This Xcopy thing is actually pretty slow. Yeah, it doesn't have the dot. Oopsie. Dude, what? Oh, because I literally, I was like, I closed it, but then we went there to look at the thing. Is simp the magic bytes in this package format? If you were to guess whether the answer is yes or no, what do you think the answer is to that question? Hey, look. Look at all these things. Bruh. This is in levels.package. Okay. Programmer. Let's just go see the file for ourselves. Wait, that's not the right one. That's the original script, Sokoban disks, run tree, data, levels. No, not levels. It's just here. Levels.package. Okay. So it's 27 megs, which is like pretty small on the scale of games that we make these days. It's not nothing. I mean, geez, dude. I remember working on consoles where that would be large. But for now, we're going to say this is a globally loaded package. All right. And I'm actually going to copy this into the working folder because I don't want to have to launch the weird exported one all the time. So I'm just going to put actually data. We're just going to put that there right now. And then we're going to test the Sokoban game. And we're going to go like this. Here. This is going to set packages active to true. Package is going to be simple package dot load package, right? All right, so we've got to import this sucker, import simple package, and we'll namespace that. Okay, so package points at that. Package is active. Get file from package. We're going to say incomplete, handle multiple packages. All right. Actually, let's just return false here so we can see the game fail utterly. And then when we implement this, we will see it happen, right? The package equals package. We're not even going to bother with the root string. The package. Assert the package is not equal to null. Okay. So, this is all fine. Right? Actually, no, we want to do the game. So now nobody is actually calling this right now. So when we look for all dot entities, right? Let me actually, so if we go to like levels dot, or did I close it out? Levels dot package. It's large, 26 megabytes. I can search for exclamation point talk here. Wait, or is it talk exclamation point? There we go. So this is a table of contents, and you see it's like all. Okay, this is actually bad. We are not putting enough distinguishing information. Literally, we put the name all for all of them. We don't want that. We want we want the file name, not the base name. Actually, let's say let's just pass it, and we'll say entry name, and we'll just pass the same thing twice. But, you know, we're reserving the right to do something else there. Okay, now I have to repackage because all that data was wrong. And keep in mind, we're not just here packaging the little amount that's going in this package. We're packaging like 20 gigabytes of game data. It's just we're putting a little bit of it in this package. When I talked earlier about how simple memcopy is the best when having control over structs, does that mean your entities don't contain any dynamic allocation? No, they do. I was just talking about with regard to like package formats like this. And like, how do you write out the fields of the file format? I think, if we're referring to the same thing. Okay. Scripts, dist, sockban, run tree, data. Levels.package. All right. TOC exclamation. That is such a good idea. Okay. Now we're also passing the wrong thing because I don't want all this. I don't want all this. I believe okay, we want this remainder here, actually. See, this target prefix is us chopping off the C colon and all that stuff. We want that. Third time's a charm, right? Oh, let's get out of this folder, though. Just in time, maybe. Why did I start a new programming language and did not iterate one of my old ones? Because this is a very, 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 very different idea than that. My ideas of what's a good programming language has evolved over time. And actually, when I started this language, I copied the lexer and parser from that one to begin with. So I sort of did iterate on it. Sort of. Okay. Boom, ba-boom. Go back here. Levels.package. TOC. Wait. There we go. Run tree data, levels, etc. Now, I think later. Oh. I don't think we want the run tree part. So I'm just going to cut that off right now because we want just data / whatever. Yeah. So for now I'm just going to do this. Assert starts with remainder run tree, so I'll know if this goes wrong. We'll clean that up later. And remainder 2 is advance remainder by 1, 2, 3, 4, 9. Okay, fourth time's a charm, just like I just frickin' said. Let's get out of there. Please make sure the manifest is up to date. Do I need the data part? Probably not, but we'll see. It's just like run tree is the actual current working directory of the game when it's running. So for now, we're just going to refer to everything relative to that. But it is true that in this package, actually data/levels is going to be redundant for every single one of those. Now, one of the things we could do is add a field in the package format that's like common root folder for everybody, right? So that you don't have to say it a billion times. That's one thing I was thinking about. I'm not sure if that's a good complication or not. Another thing we could do is just if we knew everything in this package was in data/levels, we could just cut that off all the names, and then when we mount it in the game, we could pass that root. The question is just, is that complicated that you have this invisible swap-a-rooney or whatever? I don't know. Anyway. Here we go. We're going to visit it again. Ugh. Okay, data level. Okay, this is fine for now. But yeah, they all say data levels. But that's okay, because that's relative to the working directory of the game. It's all we're really looking for right now. So now, first let's say when we load the binary entities, this is called binary save, but it has load. All right, so instead of read entire file, we're going to use this thing, right? Packages. See, we have a thing in the game called packages and a thing in the tools called package. Maybe that wasn't the right choice. Didn't notice it at the time. So we're going to call this, right? So we're going to go, instead of this, we go file data, file success, and file on disk is read entire file from disk or package, file name. For now, that's just going to, I wasn't freeing this. Lol. Defer if file on disk free file data. Okay. Great. So this should not change anything because that disk or package checks whether we mounted any packages and we didn't. So it should be going to disk, which it is because we have entities. We're in a level with stuff. That's great. We like being in levels with stuff. Okay, next. Let's go to main, and we're going to say mount general package. Let's have another overload. We're going to ignore this root parameter, but I'll leave it there. So we're going to take a string and we're going to go right. Remember we had this init from file. Let's do this. package is package, or load package. Init from file, this is in simple package because we namespaced it. Init from file, package by data levels dot package, right? Success. Oh wait, file name. We'll use you in a minute. File name, if not success, log error, unable to mount package, whatever. File name. And we're just not going to return false because these things are doomed anyway if this happens. Now, when we start out, we start the game at some point relatively early on. We know if we're doing a playtest or not. It's like, okay. Mount general package here, and we want to do this maybe if we're only in a playtest. Or actually, we have a different variable that I want to search for in a second. But for now, we're going to do it all the time. Okay, I forgot to do the following. Mount general package root, like that. That's what actually sets packages active. So we're going to do this. Lol. Okay, well, assert packages are active. What? Isn't that? Oh, no, just package is active. And undeclared identifier load package. Might be a few more of these. All right. Cool. So, this should cause the game to totally fail now because we're starting up this package, but our load asset function returns nothing. Yeah. So we have a completely empty screen with no entities. The game is running, however, right? There are no entities. What the I want my Steam bucks back. Okay. So now let's make it work again by filling this out, right? So again, eventually we might have multiple packages. We might combine the hashes from the multiple packages into one hash table or not. I don't know. Who knows? But for now, we're just going to say data found is table find the package.lookup file name. If found, return data true. Cast string. Whoops, no, recompile. Can I cast this into string? Oh, it's entry info. Return. This is entry. Return entry dot, is it cast string there? Dang it. Why not? Unable to find all these in mounted packages. Data levels, in-game particles, all dot entities. let's I thought I had it here. Did I might not have copied it over. TOC exclamation point. Data levels. Well, in-game particles. It's right there. It's right there, buddy. Let's actually, just so we know what we got here, let's just log package entries, whatever, package.entries, no check-in. Okay, well, we did some entries. No, I didn't copy it. See, these are all again. Wait. This is the wrong one. Okay. Yep. We're going to succeed in the games industry by copying the file to the right place, everybody. It's 27 megs. That's so scary. All right, rerun. Oh. There we go. Successful stream, 3.5 hours plus lots of chatting. We made a package format from scratch and our game loads from it. I'm going to do a little bit more. I'm going to have it only do this when we're in playtest mode. But then this is great because it gives us the freedom to continue packing our files together. Okay. I want to go to bed now, so this is good. All I want to do now is go back here. I want to make sure that the development version of the game can run without package and the shipping version of the game runs with package. In fact, so if I go back here, we shouldn't be able to find an all.entities, right? So because we put them all in the package, so they shouldn't be in the file system. There's still 50,000 files, but yeah, okay, so that's good. So if this one can't read the package, it won't run. Let's go back here. Package. We only want to do this. So we have this variable require source assets. This packaged variable, it was something I put in the other day. I don't think we're going to pay attention to that right now. Like this is telling, so these catalogs are how we refer to assets by simple string tags, and we're telling it to search the file system. And you don't want to do that if you're running with packages, but we don't put those in packages yet. So like this is going to change later, but here, what mount general pack? Okay. So if we don't require source, it's confusing to think about, but not requiring source assets means that we're running in like deployed packaged mode in as much as that exists. And it's still a gray area because we don't really package totally yet. But if we're doing that, then we do this package mount. Otherwise we don't. And if we don't, packages enabled will not be true. And we'll read off the disk. And we will prove that that is happening by going back to here and deleting levels.package. So we will not run with it, right? because it's not there. So now we have to be loading the loose files, which we do. And now if I go back to the packaged version, this is the one that is just loading the package, right? And we just go back here. Now, 1105. So the problem is the executable is a little bit old because, well, we actually want to test the executable we just compiled, but we can just copy it over. We don't have to run the whole packaging process again. So I'm going to go here, and I'm just going to copy Soko debug over here. We're not even going to do the release. Now this has to be running with packages by definition, because there ain't no loose files for the entities, and that works. So GG's, everybody. It's almost like we know video games. What window is this? Any questions about what we did tonight? Are there performance tests done? No. On-topic questions about what we did? On-topic questions. What if the user is not using a terminal or you would like to localize the error messages? Well, we do not provide a built-in localization system. You would provide that if you want to localize error messages. If they're not using a terminal, you have the ability to redirect where log messages go. That's a standard facility. It seems that returning an enum with an error code, no, not really. So, well, I don't know. It depends. You would have to design whatever system you want. The problem with returning an enum is it doesn't contain that much information, right? We were returning a lot of extra error information, like what the number should be at most, and then what number exceeded that, and all these things. And you can't put that information in an enum. You could define some error structs and return those that contain all that information, but then that's starting to get really complicated. You know, really the time I think to use an enum is if you expect your caller to do something different for different kinds of errors, you know, but this doesn't seem like that kind of application. Any other on-topic questions? You could print the progress on the same line with \r. Yeah, I don't want to do that. I don't know. I just never was super much a fan of that. Maybe it's fine. You know what? Let's do it. Let's do it. Let's do the user suggestion. Okay, we're gonna have to be out of this folder. We've learned that lesson. What is it? Copied. Okay, we'll do \r, and then we'll put a new line here. Okay, so the thing about that is actually other outputs happen. All right. During the packaging, I don't know if we can see it. Oh, are we still doing that at startup? Hopefully we took that out. Hold on. Let me check the game. Is it still printing a giant bomb.com. Doesn't look like it. So the problem is if we do the \r thing, that's gonna, like, all these commands are maybe outputting things sometimes. Right? Let's see. Let's see if that's actually what I said is true. We're planning on compressing files in the package format. So on some platforms now, they have hardware compression in the outer layer, and so you wouldn't want to compress yourself. But other platforms, you would want to compress yourself. So it's something that we would do. Oh, you know, maybe it's fine. You know what? We don't print other stuff. We don't print other stuff. Okay, it's fine. Now, this is a log and not a print. So, like, I don't know. That's a little bit weird. Oh. We'll see if we like this. We also could print the \r beforehand. And then the cursor will be at the end. Is that better? Maybe. All right, so now we'll actually print. We'll just print that we did all of them. Trust me, man, we did all of them. And actually, this should be +1, bro. I think. Oh. You know. Because if it indexes 0 and we finish the copy, we have copied one thing, right? Let's see if that was a disaster somehow. So when reading a package, there's no copying files. Is when you extract a zip file, you simply read the content. Yeah, I mean, if it's not compressed, there's no reason to copy the data, right? If it is compressed, there is. So that's a thing. Is this getting ready to deploy a copy to the person who's going to be testing the game? We have already done that. There is someone in the wild testing the game currently. So I think we could keep this diagnostic here because this is all the input files. And then after this, later on, we could say here's how many loose files we copied, right? Here's how many went into packages. Okay, let's actually do that right now. So we're going to have files kept loose, files into packages, and print files packaged, files into packages, and then files kept loose, all right, so while that's running, did we modify this at all? We did. Just a comment. A tiny comment. Okay, so we did all this. We are only packaging 700 files right now, but that's fine because now we have everything we need to continue out, right? So like what's next? Probably the paint data goes in with those. Then what? Probably the light maps maybe, or I don't know. Those are probably pretty big, but we'll see. The meshes can all go in one. Oh, I mean, we'll see how big the packages are, and then we'll consider breaking them up. The thing is, like, for big assets, like textures are especially big, right? For big assets like that, for a final shipping game, you probably want to break them up by zone and load and unload zones. But we don't really know what the zones are going to be yet, right? But what we could do is make arbitrary packages like texture 1, texture 2, texture 3, and just load them all at startup. Who knows? Thing is, there's probably too much texture data to... But then we end up loading them all anyway right now if you're playing off loose files and you play long enough. I don't know. It's all good, everybody. But this has been our stream, whatever it was. I just wanted to sit down and I felt like it was a solid, well-defined task to concoct a package format, implement it, make an example, and then use it actually in the game. And we have done all these things, and now let's ship it to the rest of the team. I hope I didn't do a no check-in. Let's actually look before we get... Haha, there isn't one. Use the new package format a little bit. Wonderful. That feels good. Feels good.